Assalamualaikum and good day everyone. Today we are going to proceed with our next topic, which is properties of inverse Laplace transform. Okay, in my previous video I already teach you on how to get the inverse Laplace transform by using table of Laplace transform. Okay, but this one is only valid for a single function. Okay, so if you cannot find the inverse of the Laplace transform directly from the table, you need to apply properties of inverse Laplace transform. Okay, so just the same as before this, when we involve with properties of Laplace transform, remember you have three properties: linearity, first shift, and multiplying by Tn function. When are you going to use the properties? When you cannot find the Laplace transform directly by using table. Okay, so same goes for this one. If you cannot find the inverse of the Laplace transform directly by using table, then you need to apply properties of Laplace transform, properties of inverse Laplace transform, sorry. So we also have three properties of inverse Laplace transform, which is linearity properties, first shift, and also rational function, or we call it partial fraction. Okay, so in this video I'm going to teach you on how to use linearity properties to solve inverse Laplace transform. Okay, so take a look at this one. So we will apply linearity properties if you have addition or subtraction of a function. Okay, so for example, this one in this theory state that if Laplace inverse of fs, you will get ft. If inverse of gs, you will get gt. So if you have a constant alpha and beta and you were asked to find the inverse of alpha fs plus beta gs. So as you can see here, you need to split the function into two functions, the same as we did in the linearity properties of Laplace transform. Okay, and you need to factorize the constant. Okay, so instead of finding the inverse of this one, now you just have to find the inverse of fs plus the inverse of gs. So you will have ft plus bgt. Okay, because okay, as you can see, let's say for this example here, okay, this one, as you can see, this function, you cannot get the inverse of this function directly from the table. Okay, because you have a combination of variable plus a constant for the numerator part. Okay, for the denominator part, you don't have any problem because in the table of the Laplace transform, we have s squared plus a squared. But as you can see here, s squared plus a squared, but for the numerator part, this is s. And this is, for this one, this is a. So there is no such thing as s plus a or s minus a for the numerator part. Okay, so that's why we need to apply linearity properties. So let's take a look at the first example here. We are going to solve this one. Find the inverse of this Laplace transform. Okay, so the first step is you need to split this one into two functions. Okay, how did I know that I have two functions? Because you have this one here, the first one plus the second one. Okay, remember when we split the function into two, this one remain as one term. Okay, you cannot split this one as 3s over s squared plus 8 over 4. No, that is wrong. Okay, so to get the inverse of this function, so Laplace inverse of 3s plus 8 over s squared plus 4 is equals to, so as you can see here, what is your constant? 3 is your constant and also 8 is your constant. So you need to factorize. So you will have 3 Laplace inverse of So what is the first function? S over s squared plus 4. S over s squared plus 4. So this is your first function. The second one, plus. So what is your constant here? 8. So inverse of, so if you factorize 8, so you remain with 1 over s squared plus 4. Remember, I told you in my previous video, if you have any constant, just factorize it first, so that it is easy for you to multiply by a constant and divide by the same constant. Okay, so as you can see, this one you cannot get directly from the table, but when you split into two functions by using linearity properties, so this one you can get directly from the table, and also this one. So as for this one, before you can find the answer by using table of Laplace transform, you need to define what is your a. This is a squared. So you know that a squared is equals to 4. So your a is equals to 2. Same goes for this one. You know that your a squared is equals to 4. Your a is equals to 2. Okay, what else we should do? This function will be cost function. Why? Because you have s variable for the numerator and this is plus. Okay, this one will be sine function. Why? Because you have a constant here and this is plus. By now you should be able to recognize this function. If you inverse, you will have what function? Okay, if you still don't get the first part of the inverse Laplace transform, you have to recall my first video on the inverse Laplace transform. Okay, you have to master in that one first, then you can do this one. Okay, so for the first part you don't have any problem. Why? Because when you have s over s squared plus e squared, so you directly got cos 80. Since your e is equals to 2, so you will have cos 2t. Right. Okay. So for the first part, you have this one is equals to 3 cos 2t plus. Okay, now this one. So as I told you before, this one will be a sine function. Okay, but take a look at this one. If you want it to be a sine 80 function, it should be a over s squared plus a squared. So from here you know that your a squared is equals to 4 and your a is equals to 2. So for this function to be sine 2t, you need to have 2 for the numerator part, isn't it? Because a is equals to 2. But here you have 1. So you need your a is equals to 2, right? So you need to multiply by 2 and divide by 2. Remember, every time we multiply by a constant, we need to divide by the same constant. Okay? So you will have 4 sine 2t. Okay, I didn't change the problem at all, because if you cancel out this one and this one, you will have the same function. 1 over s squared plus 4 times 8, you will have 8 over s squared plus 4. Okay, so that's why every time you multiply by a constant, you need to divide by the same constant. Okay, so that you don't change the question or the problem. Okay, so we settle with the first example. Okay, so I just recall it back. So the first step is you need to split the function. Okay, then factorize the constant. And if you can get directly from the table, then find directly from the table. But as for this part, you need to do some modification. So you have to multiply by a constant and divide by the same constant. Okay, so now let's take a look at the second example. Like say you have your fs is equals to negative 4s plus 7 over s squared minus 16. Okay, So again here you need to apply linearity properties because of plus here. Okay, so you know that you will have two functions. Okay, so the inverse of this function will be Laplace inverse of negative 4s plus 7 over, s squared minus 16 is equals to, so what is your constant? Your constant is negative 4 and also 7. So you will have, so factorize negative 4. So you are going to find the inverse of s over s squared minus 16 plus, so factorize the second constant, which is 7. So you need to find the inverse of 1 over s squared minus 16. Okay, so again here define what is your a. So you know that this is your a squared. So a squared is equals to 16. So your a is equals to 4. Same goes for this one. A squared is equals to 16. So your a is equals to 4. So by referring to the table of the Laplace transform, you know that this one will be cos hyperbolic function. Why? Cos, because you have s for the numerator part. Why hyperbolic function? Because this is negative sign. Okay? And for this part, you will have sine hyperbolic function because this is a constant and this is negative sign. So therefore, the inverse of this one is equals to negative 4 cos hyperbolic at. What is your a? 4t. Okay. For this part, you know that your a is equals to 4. So supposedly, for the numerator part, it should be 4. So therefore, you need to multiply by 4, divide by 4. Okay. So you will have plus 7 over 4 sine hyperbolic 4t. Okay. Actually, this is simple as long as you know the concept. Okay. You have to refer to your table of the Laplace transform here. If you cannot get directly from the table, then do some modification or apply properties. That's it. Okay. Okay, let's take a look at the third example, which is this one. If let's say your Fs is equals to 3s plus 5 over 16s squared minus 9. Okay, what is the difference between this function and these two functions that we already discussed? You still need to split the function, correct? You still need to factorize a constant for the numerator part, that is also correct. What is another difference? The difference between this function with these two functions is that, as you can see, there is a constant more than one for the s squared. As you can see here, this is s squared. This is also s squared. But for this one, you have 16 s squared. Remember in my previous video, I told you if you have any coefficient other than 1 for the s squared, so you need to factorize. And when you factorize this one, it will also affect this constant. Okay, so let's try to do it. So the inverse of this one is equals to over 16s squared minus 9 is equals to, so what is your constant now? So you know that your constant is 3, 5 and also 16. You need to get rid of the 16 so that you can refer to the table of the Laplace transform. Okay, because as you can see in the table of the Laplace transform here, the coefficient of s squared is always 1. Okay, so you don't need this value 16. So you need to factorize it. Okay, so the first function will be 3 over 16. Inverse of s over s squared minus, so what will happen to the constant, this one, to this constant? It should be 9 over 16. Remember, you need to do something here, because if you don't divide by 16, you already change your problem, because when you times 16 times by s squared, you will have 16x squared minus 16 multiplied by 9, you will never get 9, isn't it? So for you to get this value 9 here, you need to have 9 over 16. So that when you cancel out this one, you will end up with 9. Okay, so this is the first function. Plus, so what is the second function? 5 over 16. Inverse of, so when you factorize 5, you will end up with 1 here, you remain 1 here, over, this one is the same as the previous one. You will have s squared minus 9 over 16. Okay, so what is the next step that you should do? Is define what is your a. Okay, you know that this one will be cos hyperbolic, this is sin hyperbolic function, but you need to know what is your a. Okay, so for these two function here, your a squared is equals to 9 over 16. So your a is equals to 3 over 4. Okay, so for this part, you will directly get cos hyperbolic 3 over 4 t. But for this one, since your a is equals to 3 over 4, therefore what should you do here? You need to multiply by 3 over 4. This one here divide by 3 over 4. Okay, why I need to multiply by 3 over 4? Because your a is equals to 3 over 4. Okay, so therefore the inverse of this function is equals to 3 over 16 cos hyperbolic 3 over 4t. So this is for the first function. Plus, so 5 over 16 divided by 3 over 4. So you can just press your calculator, you will have 5 over 12. Sine in hyperbolic 3 over 4 t. That's it. Okay, this is much more difficult compared to the previous example, because your a is a fraction. Okay, so multiply by a fraction, so you need to divide by a fraction. That is one case. Another one is because the coefficient of s squared is not 1. Okay, so therefore you need to factorize 16, so you need to factorize 1 over 16. Okay, so let's take a look at the last example. Like say you have your fs is equals to 6s plus 5 over 9s squared plus 16. Okay, so you need to apply linearity properties because you have two functions here. So define what is your constant. 6 you need to factorize, 5 is also a constant, and the coefficient of s squared here, because you know that you should get this one s squared only, so that's why you need to factorize 1 over 9. Okay, so by using linearity properties, the Laplace inverse of 6s plus 5 over 9s squared plus 16 is equals to, so 6 over 9 is a constant. So you need to find the inverse of s over s squared plus 16 over 9. Okay. Plus, what is your second constant? 5 over 9. So the inverse of 1 over s squared plus 16 over 9. Okay. So define what is your a here. Your a squared is equals to 16 over 9. So you know that your a is equals to 4 over 3. Okay. So as for the first part here, you directly will get cos 4 over 3 t. But this one you need to do something because the numerator is 1. But it should be 4 over 3 because your a is equals to 4 over 3. So what you should do is multiply by 4 over 3. Therefore you need to divide by 4 over 3. Okay. So therefore the inverse of this function is equals to, so 6 over 9 you can simplify. You will have 2 over 3 cos 4 over 3 t plus, so 5 over 9 divided by 4 over 3 will give you 5 over 12. Okay, I'll show you how. 5 over 9 divided by 4 over 3. So you have 5 over 12. This is sine function. So what is your a? 4 over 3 t. That's it. Okay. So as you can see here, although we have a complex function here, your fs, but you can get the inverse of that of this particular function when you apply properties of inverse Laplace transform. Okay. So you should now be able to know when are you going to apply linearity properties. Okay. And what should you do if after you apply the linearity properties? What should you do if you cannot get the inverse directly from the table? So do some modification. Okay, if you multiply by a constant, then divide by the same constant. Okay, so we are done with the first properties, which is linearity properties. So in my next video, we will take a look at the second properties, which is first shift properties. Okay, so try to go through back this example and try to do the exercise that I give to you in the notes. Okay, so if you have any problem, please let me know by using either you can reach me by using WhatsApp also or at Modu. Okay, so I shall see you in my next video. So thank you. Wassalamualaikum.